Now that we've done our little refactor, we're going to start to run this statement of code right here for different values of k. We'll observe the accuracy for each different run, and then we'll eventually pick some value of k that we'll move forward with throughout all the rest of the work we're going to do on this project. So to vary the value of k, we're going to essentially wrap this entire block right here with a for loop. We'll change the value of k, and then we will rerun our KNN algorithm considering a different number of top records. Now we could definitely do a for loop as we did previously, but again, a lot of things that we could write with for loops can be very easily recreated with Lodash instead. So here's what we're going to do. I'm going to pull open my Lodash documentation again, and I'm going to look up a function called range. So with range, we can pass in a start number and an end number, and that will produce an array for us. So a good example is right here. 1 to 5 is going to produce an array 1, 2, 3, 4. So the end index right there is not inclusive. It stops 1 short. Once we use range to produce this array, we can then use this array as all the different values of k that we want to test our algorithm with. So let's give this a shot. I'm going to flip back over, and right above our accuracy statement, I'll do a range, and I'm going to test out values of k from how about 10 to like 15. And then for each of those different values of k, so I'm going to put in a for each statement here, I'm going to put in my k as the argument, because that's what we're treating it as here, and then I'm going to wrap this entire block of code inside of that for each, like so. So now we're going to iterate from 1 to 14 in this case, because remember the 15 is not inclusive. So we're going to run from 1 to 14, and we're going to do an accuracy test for each of those different values. Now, the last thing we need to make sure that we do is we need to make sure that we actually use this value of k when we run our KNN algorithm. Right now, our value of k is hard-coded up here at the top. So I don't want to hard-code this thing anymore, so I'm going to delete the const k equals 3 at the very top, so that's totally deleted. And instead, when I run my for each, I'm going to pass in the value of k to my KNN function call. So as the third argument, I'll pass in k like so. So right there, now every time we call the KNN function, we are passing in the data that we want to be used as the kind of similarity data set, the point that we're trying to make the prediction for, and the actual value of k. So now I need to make sure that down inside of my KNN function right here, I receive that k argument like so. And remember, k was used on that step right there. Okay, so this looks good. Now I'm going to save this, and then I'll flip back over to my application. I'm going to refresh the page. I'm going to get my initial data set by dropping 10 at 10, as we did previously. And maybe I'll get a little bit more data, so I'll do another 10. Okay, cool. And then finally, I'll click on my Analyze button. All right, so for all of our different values of k, we printed out an accuracy report. One thing we kind of forgot to do is actually print out the value of k that's being used on every given step here. So let's try putting that into the little console log here as well. We'll say something like, how about for k of k, accuracy is blah. So now we'll get a nice little statement that says, for a given value of k, our accuracy is whatever it is. Now let's try doing this again. So I'll do another 10 at spacing 10. And let's get just a little bit more data. I'm going to run that one more time. By the way, you might notice that we're getting more balls over here on the left-hand side than it looks like we are on the right-hand side. The only reason for that is that I arbitrarily capped the number of balls that can be dropping at any given time, just to prevent you from accidentally locking up your browser by spawning too many balls. So you see, if I click drop really quickly, like I'm dropping as fast as I can right now, it will only allow about 700 unique balls to be created at a time. So that's why you're sometimes seeing fewer balls ending up in these buckets over here. It's because if there's a cap at any given point in time, it's going to first spawn the balls on the left-hand side, and then it might run out of space or kind of space to spawn more balls by the time it gets to the right-hand side. When it comes to our KNN algorithm, it doesn't make a big difference because all we need to make sure is that we have data readings from all over this entire board. Okay, just a quick aside, I thought you might be curious. Okay, so now that we've got our data set, we will analyze it and see our report here. So for all these different values of k, it looks like we are ranging in accuracy from 0.2 all the way up to about 0.5 or so. So that's definitely, not the worst. Again, our benchmark is 10%. If we guess randomly, we would be correct 10% of the time. So even an accuracy of 0.5, and technically even an accuracy of 0.2 is better than random. Now, one thing that might be affecting these accuracy ratings right here is the fact that we are only using a test set size of 10 records. 10 is kind of a little bit small, and we could definitely try to make predictions for far more records than this and try to get an even more accurate rating to say that a given value of k is better than the others. And one thing I want to tell you about here is you don't want to run your test set too high. If you start putting in values of like 200, that means that you're going to run the KNN analysis 200 times 14 times. And that would possibly lag up your machine just a little bit. So I think that maybe I'll settle for something like 50. And I'll try this again. So I'm going to save the file. I'll do my refresh. I will get my initial data set. And I'll drop one more. So that was another good time where you saw the number of balls was definitely capped. It only spawned balls on like the first 3 quarters or so. Okay, that's definitely enough data. So I'll do analyze. And you'll notice how it took that time a little bit of, you saw that kind of like little delay as it calculated each step. We're definitely getting to the point where my laptop even is taking a little bit of time to run this analysis. I have a rather modern laptop myself. It is a very, very new high-end model. So if you're on an older laptop, it might take you a little bit of time to get through each of these steps. Okay, so this time around, our accuracy ratings are dramatically different than what we had before. Before we were ranging from like 0.2 all the way up to 50 or so. But now that, or excuse me, 0.5, like 50%. But now that we are including more guesses or more tests inside of this test set, we can see that the rating is a little bit more consolidated, all the way from 0.28 to 0.18, and then 0.26, right around 0.2 to 0.3, or about 20 to 30% correct. And it looks like we've got a good little bump in accuracy around 10 and 11, where we get up to 0.3, and then even down at a K of 14, we get to 0.34. So without a doubt, we could definitely play around with the value of, or the range of Ks that we test, and we could also play around with our test set size quite a bit. It's definitely up to you where you want to draw the line and eventually say, okay, I'm happy with the K value here. As a quick test, I'm going to run one last analysis. This time I'm going to bump up to 100 records, and I'll expand my range of K to about like 20 or so. Now, if you have a slow laptop, if you have an older model laptop or desktop or whatever you're using, I encourage you to be kind of careful with these numbers because they might entirely lock up your browser if you put them too high because you're doing too much processing. So do be careful with these numbers as you start to change them. Okay, so I'm going to do one more analysis here and see if I can get a little bit more definitive value for K. Now, as usual, I'm going to get some initial data set. So I'll do my drop. I'll do a drop again, and I'll do one more time just for really good measure. And then finally, I'll do my analysis. All right, there we go. So now with an even larger test set size, we can see some even more fine-grained statistics on how accurate we are. You'll notice that, again, it starts off with an accuracy of about 0.3. I think last time we were maybe at 0.24 or something like that. And it looks like our accuracy drops off around a K of 2. That's like actually kind of interesting, but it kind of makes just a little bit of sense. Because when we have an accuracy of 2, if we see, say, bucket 6 and bucket 7, then it's kind of random which one will be picked. And if it turns out that bucket 6 was correct, well, we weren't quite able to build consensus, where we're able to build consensus more easily when we start getting to these larger numbers. Now, it looks like I'm going from 0.31 and then down a little bit, and then I start to go back up when I get to around like 8, 9, and 10, which is what we actually saw previously on the last iteration as well. So it kind of looks like a sweet spot is on the higher side of like 7 or 8. So maybe a K of 10 in general would be a really good spot to land for the analysis of our data set with just this one single feature of the exact drop position. So I think that moving ahead, at least as long as we're only using the drop position as the only feature that we're considering, I might use a K of 10 here, because it looks like that's kind of a happy medium as I start to vary my test set size. Right around 10, it looks like I'm starting to get a peak in my overall accuracy. Now, one quick thing I want to mention here, I know this section is running just a little bit long, just one last thing. One thing that you might try changing is the spacing at which you drop these numbers as well. You know what, let's just do it really quickly. Doing this little testing is really, really fun for me personally. So let's do this one more time. I'm going to drop one ball every 1 pixel. So 1 and 1. If you do 10 and 1, you're going to definitely run into that ball cap very quickly. So try 1 and 1 as your spacing here. And I'll again do some initial data. And I'll do it one more time. And then I'll run my analysis. Okay, there we go. Now, you'll notice that when we start to drop down that accuracy to 1 and 1, for some very interesting reason, it looks like we're falling quite a bit, about 10% across the board, even as we get up to those K of 10, 11, and 12, where we saw around 0.3 before, we now see like 0.22, 0.25, 0.26. So without a doubt, there definitely seems like there's a lot of different variables here that we could play around with and hopefully come to some consensus over the value of K. Like I said previously, it looks like 10 in general is a pretty happy number to sit with. And that's just for this application that we're working with. It might be that on different problems with different data sets, different values of K come up with dramatically different results. So in general, a good way of approaching this is to just run the KNN analysis multiple times and eventually pick out a value of K that kind of seems like you're getting to a nice sweet spot. Okay, so again, sorry for the long section. Let's take a quick pause right here and we'll continue in the next section.